You've likely all seen the news by now. NASA found a possible sign of life on Mars. Tiny dark patterns, barely visible to the human eye, have suddenly become the loudest echo in the universe. Small, silent marks that could rewrite the story of life itself. If what we're seeing is real, this discovery would stand beside the moon, landing a turning point not just in science, but in how humanity sees itself. But Mars has fooled us before. We've chased mirages in its dust, followed whispers that turned into silence. From the Viking landers of the 1970 seconds to meteorites once thought alive, every promise has ended the same way with doubt. And yet, this time feels different. The readings are sharper. The chemistry doesn't lie. Something deep beneath the Martian surface is trying to speak. And for once, we might finally be listening. What Perseverance found in Jezero Crater has left scientists breathless and could change everything we thought we knew about life itself. So the question remains, have we really done it this time, or is Mars about to break our hearts again? In February 2021, a six-wheeled explorer touched down on a world of dust and silence. NASA's Perseverance rover landed inside Jezero Crater, an ancient Martian lakebed that once shimmered with flowing water. Long ago, rivers carved their way through the crater's rim, pouring sediment and clay into a vast basin that might have been home to life. For scientists, Jezero is more than a crater. It's a time capsule. The layers of clay here can trap chemical traces the way fossils trap bones on Earth, preserving whispers of biology that may have vanished billions of years ago. Each grain of dust could hold a story from an era when Mars was blue, wet, and alive with potential. That's why Perseverance didn't just take pictures. It drilled into stone, sealed samples inside titanium tubes, and left them waiting tiny glass coffins of Martian history for a future mission to bring home. What it's collecting isn't just rock, it's evidence, waiting for a verdict, but no one expected what Perseverance's camera would find next something that looked alive. Inside a rock, as Perseverance rolled along the dry channels of Neretva Vallis, its cameras caught sight of a strange formation. A slab of stone unlike anything else around it. It came from a layer scientists call the Bright Angel Formation. Two of the rover's most advanced instruments, Pixel and Sherlock, were turned toward the rock. The readings lit up with patterns of clay and fine silt materials known on Earth as perfect fossil keepers. When the rover zoomed closer, something unexpected appeared. Across the surface were tiny circular markings, dark at the edges, pale at the center like miniature rings frozen in time. Scientists named them Leopard Spots and poppy seeds. Each spot measured between 200 micrometers and 1 millimeter in diameter, rich in iron and phosphorus. The same elements tied to energy and life under magnification. They looked eerily familiar, like microbial colonies fossilized in stone. The instruments also detected traces of organic carbon, the chemical backbone of every living thing we know. The discovery sent a ripple through the scientific community. If these patterns weren't biological, what else could shape matter with such precision? And when scientists saw the iron rings, they realized this wasn't random chemistry. Something was changing the rock from the inside. The closer scientists looked, the stranger the evidence became. Within the same formation, Perseverance detected two key minerals that caught everyone's attention: vivianite and iron phosphate, and greigite and iron sulfide on Earth. These minerals don't just appear on their own. They form in the presence of bacteria, tiny organisms that breathe iron instead of oxygen. These microbes, like the Geobacter family, take in iron 3 oxide and release iron 2 as ways to process known as chemosynthesis, using chemistry instead of sunlight to survive. They eat rust and breathe metal, thriving in darkness. In mud. In silence, that same pattern of iron reduction appeared in the Martian samples. The texture, the chemistry, even the layering all hinted at a reaction, once driven by life. Water, organics, and iron reduction, the holy trinity of microbial life. But before NASA could celebrate, the scientists hesitated. They asked the one question that separates belief from proof. What if this wasn't life at all? Science begins by trying to prove itself wrong. That's its quiet strength, the discipline to doubt, even when the evidence feels right. So the Mars team began an elimination game. One by one, they ruled out every lifeless explanation. High temperatures. Impossible. There were no signs of volcanic activity nearby. No heat scars in the surrounding terrain. Maybe chemical reactions in an acidic environment. The energy required would be enormous. And there's no trace of such extremes. Could hydrothermal vents have done it? Water and heat meeting underground. No evidence of that either. No fractures. No mineral veins. No pressure release. Each hypothesis fell away like layers of Martian dust, leaving something stranger behind something that didn't fit. Then came the detail that broke the pattern. A tiny green crystal glinting under Percy's camera. A fragment of olivine. That small discovery flipped the investigation on its head. That tiny green rock changed everything and killed the acid theory instantly. On Earth, olivine dissolves almost instantly in acid. Its presence on Mars means one thing: the environment couldn't have been acidic. The very chemistry needed to explain those strange spots no longer made sense. That left scientists staring at an uncomfortable truth. If acid couldn't shape them, what could? And yet, NASA has been here before. Hope has a long history of betrayal. In 1976, the Viking lander ran a groundbreaking experiment. It fed Martian soil nutrients tagged with radioactive carbon-14. The soil reacted exactly as if microbes were breathing. For a moment, the world believed we'd found life. But decades later, we learned the reaction came from oxidizing chemicals, not biology, a false positive. In 1996, a meteorite named ALH 84001 stunned the world. Under an electron microscope, it showed tiny worm-like shapes, the supposed fossils of Martian bacteria. Even the President of the United States made an announcement. Years later, it turned out to be nothing more than minerals shaped by water and heat. Then came 2008. NASA's Phoenix lander found perchlorate in the Martian soil, a compound that destroys organics when heated. Once again, what looked biological was just chemistry, pretending to be alive. Each time we thought we'd found life, Mars whispered, "Not yet." So if this one isn't another false alarm, we're standing on the edge of history. There's only one way to know for sure: bring the rock home. What Perseverance has found on Mars may change science forever. But until that evidence is tested here on Earth, it's still only a question. That's why NASA and the European Space Agency designed one of the most ambitious operations in human history, the Mars Sample Return Mission. Phase 1 is already complete. Perseverance drilled into the ancient mudstone at Chayava Falls, sealing a tiny core known as Sapphire Canyon. Inside that thin cylinder of dust may lie the answer to a billion-year mystery. Phase 2 will send another spacecraft to Mars. Its job land near Perseverance, collect those titanium tubes, and launch them into orbit, the first rocket ever fired from another planet. Phase 3 will rendezvous in orbit, capture the sample capsule, and bring it safely back to Earth, a journey spanning years, billions of miles, and the hopes of an entire planet. The mission's price tag is staggering $11 billion. Delayed from 2033 to 2040, yet still ranked the highest priority in every NASA ESA roadmap, because that little tube of Martian dust could rewrite everything we know about life itself. And as the plans unfold, NASA introduces a new way to measure belief, a ladder of proof known as the Confidence of Life Detection Scale. Because before we call it life, NASA wants proof that climbs the 7 levels of certainty. NASA's Confidence of Life Detection Scale, or COLDS, sets a new language for discovery. It runs from level 1, possible chemistry, to level 7, independent confirmation of life. The Jezero Crater finding sits somewhere between levels 3 and 4, potential biological signature and strong evidence. But if that Sapphire Canyon sample makes it back home, and laboratories across the world confirm its biology, the discovery could soar to level 6, one step away from certainty. And if we ever reach level 7, if life is confirmed in more than one place, it would shatter the idea that we are unique. Think about it. If it's just one planet, we're alone. But if it's 2 Earth and Mars, then why not 5? 5,000. 5 million life wouldn't be a miracle. It would be a pattern written into the universe itself. The implications ripple through the Drake equation, the formula scientists use to estimate alien civilizations. That single coefficient, the fraction of habitable worlds that actually develop life, would leap from near 0 to almost 1. The universe would feel suddenly crowded. And perhaps that's the point. Maybe Mars isn't just a planet waiting to be explored. Maybe it's a reflection of us. Frozen at the dawn of biology. A mirror showing where we came from and what we might become. So what do you think? Is this level 3 or level 6 already? Tell us your guess, and as always, stay curious, stay critical,